Now, I need to do a segue for our first guest presenter. And I'm going to set the stage for them by talking about some of the work that we're doing in mapping and cartography. Of course, this is our bread and butter. Everybody that is watching this broadcast right now is here because you use maps to communicate. All the work that we do has a location coordinate to it. Everything is location based. And we use location, of course, to communicate. Our medium for doing that is maps. We're constantly working on improving the way we can support the work that you do with mapping and cartography. But sometimes you just need that little extra something special. And this is where I'm going to introduce Ryan Rudzik of TEP Barnett, where Ryan is going to walk us through a novel way that he's used visualizations to improve his operational efficiency. Ryan?
My name is Ryan Rudzik. I work for TEP Barnett. We're an affiliate of Total. We operate more than 2,000 wells in the Barnett Shale in a highly urbanized environment. I'm here today to share our production web map, along with a novel solution that we came up for visualizing production over time. It's built using FME and ArcGIS Enterprise. Our production web map application contains some common elements familiar to many people in our industry. We display things like field route polygons, wellbore symbolized by artificial lift type, daily gas bubble volumes, daily water bubble volumes, daily line pressure bubble volumes, and gas to liquid ratio bubbles. A very unique feature of our production web map application is what we call circular charts, which are rendered using an FME process that I developed. Their appearance is inspired by chart recorders, which are machines with paper charts that rotate over time. They have mechanical armatures that hold pens that move across the paper based on the sensor or meter readings. Constructing our circular charts required only two basic data sets. We have a well bottom hole point feature class from our geodatabase, and we have daily production history tables with gas, water, and line pressure. FME was the right tool for transforming the raw data into circular charts. Each chart represents 365 days of production history for every TEP well that produced in the past year. FME exports these features as simple polyline and polygon feature classes to our geodatabase. It takes about 40 minutes each night to rewrite the data set. These are the basic steps in FME to produce our circular charts. We start in step 1 with a well bottom hole location. In step 2, we merge our well location and our daily production using a unique identifier. Step 3, the FME offsetter uses polar coordinates to plot daily volumes. Step 4, the FME bufferer offsets grid lines for every 500 ground units. Step 5, the FME line builder constructs the time divisions at the first of every month. In step 6, the FME point connector turns our plotted points into polygons. And then in step 7, the FME line on area overlayer intersects all of our geometries and keeps only the lines that overlap the polygons. There is no circle chart transformer in FME. I had to think in simpler terms and use standard transformers for basic geometry manipulation, plus some math. There's two basic concepts that were necessary to render these charts. Polar coordinates were used to plot the daily values in the charts. They require 3 variables: origin, angle, and offset. The origin used the bottom hole location. The angle was translated from the production date, day interval. The offset was the production volume used as distances in ground units. But before I could do any geometry operations, I had to do some data scaling. We used min-max normalization. Scaling was necessary to make the overall size of the charts more practical, given the typical well offsets in the Barnett Shale. ArcGIS Desktop was used to design the final visualization and the appearance of the circular charts. This is where I designed the symbology. Scale dependencies were applied to the geometry and the labeling to optimize the display performance and visual clarity. Scale dependencies provide the user with no more detail than what was practical at any given scale. The resulting visual was published to ArcGIS Server for use in Portal. This is a gallery of our circular charts. As you can see, there are many varied results. In some of these displays, you can clearly see recently recompleted wells. You can see inconsistent production results. You can see where there's been steep production declines or where weather or operational events have occurred. This is a live view of our production web map. Initially, what the user sees is the bubble map. Right now, we're seeing the daily gas volume bubbles for the most recent day's production. As a user zooms into the locations, you can start to see more detail. We have labels turning on that are giving to the most recent day's gas production. As we get a little bit closer, you'll see that it switches over to the circular chart representation. You start to see a simple profile of the circular charts. As we get a little bit closer, it turns on more detail. Another step closer, and you start to see the grid lines for the circular charts. And then closer yet, and it turns on labels representing the volumes and the time declinations of the charts. In the center of the chart, you can see the most recent day's gas production, water production, and line pressure. In this example, you're seeing a few wells that were recently recompleted. So they were offline for a portion of the year. They came on very strong, and you can see a steep decline, which is pretty typical when a well is brought back on. Looking at another example, we can see a group of wells that have had sporadic results over the past year. Those are potential candidates for workovers. Looking at another area, we can see a couple of wells that have had fairly consistent results over the past year. Something that stands out, you all recall the weather event that we had this spring in Texas, and it caused a lot of problems for a lot of operators, and it's clearly marked on these charts. You can see that they both have this drop-off in production and this increase in line pressure as a result of that event. So, results and lessons learned. Users want to understand production spatially. Spreadsheets and standard bar and line charts are not always enough. Some of the things that our production web map application helps users with are weather events and why they affect some wells more than they affect others, or production impact from pipeline maintenance. Well communication, where water or gas migrates to a location next to it after it drops from another well, and understanding production decline over time. It also helps identifying good candidates for workover operations. Users want to understand production spatially. Spreadsheet and standard bar and line charts are not always enough. Our production web map is used daily and has been very beneficial to users from our operations and reservoir groups. Some of the things that our production web map application helps us understand are things like it quickly allows a correlation between a dip in production and an increase in line pressure to be correlated without the need to drill down. Production impact from pipeline maintenance like pigging operations. Well communication, where water or gas migrates to a location next to it after it drops from another well. And with understanding production decline over time. It also helps in identifying good candidates for future workover operations. Thank you for your time and for watching my presentation. I look forward to answering your questions at the end of the session.
Thank you very much, Brian. That was a absolutely one of the most effective and creative ways that I have seen anybody visualize production information. And I'm sure you're going to have quite a bit of questions on that at the live question and answer here pretty soon. But looking back at your presentation, some of the things that I really took away from it was that making a big impact can be, and I say in quotes, a simple solution by simply changing the way that you visualize the information that you're trying to communicate. And that's absolutely what you did with those beautiful polar charts for the well production. So great looking application. And what I think you also did really well was determined how you could leverage the technology. In this case, you used quite a bit of work in FME to funnel that into ArcGIS and actually use a web application to communicate that. And then lastly, you had a good understanding of the problem that you were trying to solve and the problem that your peers at TEP Barnett were struggling with, and you came up with a creative solution, and you brought your expertise to the table to help them solve a problem. So really interesting visualization, and I'm really glad that we start off our sessions today with starting with visualization, mapping, and cartography, and helping our business folks actually make heads or tails of what they're trying to do.